Hello students, so we are discussing KVPY 2020 SA Physics section part 1, and we are now looking at 12th question of Physics section, which becomes question number 27 of the paper. So this question is based on projectile motion. The question says that a performer throws an apple towards a hoop held at 45-meter height by another performer. So this is the hoop, and this is the horizontal distance given to us as 25-meter, and this is the vertical distance given to us as 45-meter. So a person targets this hoop and throws an apple or a ball, I think an apple, and at the same time the hoop is being released. So the hoop will begin to fall down. The apple will not go on the straight line trajectory. It will probably it would have followed a trajectory somewhat like this, but when the hoop would be somewhere here, the apple would pass through the hoop. Okay, this is a very common example. Like there is one such question in the very popular book Concepts of Physics Part 1 at C. Verma, where a monkey was climbing from maybe a tree trunk, and the monkey releases the tree trunk, and at the same time a hunter fires a bullet towards the monkey, and the bullet still hits the monkey. Because this is what happens, you aim at something directly towards something, and if you shot a bullet, or if you throw the apple or the stone directly aiming at this body, uh, the body if the body is released at that very instant, then the two hit. And why does that happen? Because to understand this, uh, this was having an acceleration of g in the downward direction. Even this apple or bullet or whatever it was having an acceleration in the downward direction, which is also equal to g. So what happens is that their relative acceleration becomes zero, which means that their relative velocity becomes constant. So in frame of the hoop, if the ball was thrown with a certain velocity towards itself, then because the relative velocity is zero, the path of the bullet will appear to be a straight line when seen from the hoop. And so this apple is supposed to pass through the hoop. Okay, so now then, with this thought in mind, let's solve this question. So this distance will be half gt square, as it was free fall. Here t is the time after which the apple passes through the hoop. Okay, and this 25-meter we can calculate. We can write the equation as 25 is equals to v naught cos theta into t. Now there is something important that we should pay attention to, that we know this vertical distance, this is 45-meter. We know the horizontal distance, this is 25-meter. So we are in a position to calculate the value of tan theta. Okay, if I do the calculation here, tan theta will come out to be 45 upon 25, which is like 9 by 5. And once you know the value of tan theta, you can readily calculate the value of sin theta as well. It will come out to be 9 divided by root of 106, and cos theta, it will come out to be 5 divided by root of 106. So we are aware of the value of sin theta, cos theta, tan theta. So using this value, we can substitute the value of v naught here, we can substitute the value of cos theta here, we will get the value of t. Okay, so the value of t would be 25 divided by 24 into cos theta. Cos theta was 5 divided by root of 106. So this is time after which the apple passes through the hoop. Now the hoop falls a height of half gt square. So the height above the ground, that is what has been asked in the question. This height can be calculated very easily by, I'll write it here. So h is 45 minus half gt square. So we have to just finish this calculation here. So 45 minus half, let's consider g as 10, and t square will become, let's cancel few things here, it will become 5. So 5 into 5 into 106 divided by 24 into 24. So we have to finish this calculation. On doing that, we will get that this number is approximately 23, which means that the answer that we are going to get is close to 22. Okay, so out of the given option, I think B option will match closest with the with what the value that we are getting after finishing the calculation. So B would be the right answer. So I hope you understood this question, guys. And if you have come across that question from HC Verma that I just spoke of, most probably you would have done this question also. And if you found this concept new, guys, think about this, think about the situation, think about the fact that relative acceleration was zero and hence the path should appear as a straight line, and install this idea in your brain so that next time when you come across such a question, you should be able to do this. All the best, guys. I'll see you in the next question now.